Good morning, Radnor scientists. Today we're going to investigate lesson 6 from the sinking and floating unit. The lesson is called Making a Sinker Float. Think and wonder, what happens to the weight of clay when you change its shape? Will the weight change or will it stay the same? Today you're going to watch an investigation into these questions. You're also going to try to find a way to make the clay float. So, scientists, I have a cup of just tap water here. I've got a lump of clay in a sphere, a 3D circle, and I've got my calibrated spring scale. So you could see it's got marks indicating how many paper clips each of the how far the metal bar came down each time you added a paper clip. So it's a calibrated spring scale, a tool that we can use to measure small objects around the house. For example, we've got the wooden cylinder. You guys probably watched this investigation already. It's much easier to have a lab partner here. So you've got a wood cylinder hanging from the calibrated spring scale, and that's at about 8 paper clips in weight. You've got the polyurethane cylinder. Your polyurethane cylinder is at about 14, 15 paper clips on this calibrated spring scale. Remember, each calibrated spring scale could vary slightly, but we're going to say this is about 14.5 paper clips. Now what I've got here is a lump of clay in the shape of a ball or a sphere, if you will, and that is also rated about 14 or 15 paper clips. So what will happen when you make them the same shape? So we've got the same shapes. We've got cylinders. Cylinder 1, acrylic, wooden, polyurethane, and a clay lump. And let's watch what happens here. Polyurethane floats. Wooden cylinder floats. Acrylic cylinder sinks. Clay lump in the shape of a cylinder sinks. So we've got 2 sinking and 2 floating, all the same shape. Hey scientists, so what did we discover there? We discovered that half of our objects floated and half of them sank. The sinkers were the clay cylinder and the acrylic cylinder, which is practically invisible inside the clear liquid, the water. Then the polyurethane cylinder floated, as did the wood cylinder. So what we're gonna experiment with is, can we make one of these sinkers float? Making a sinker float. And what role does shape have in that process? So this 4 things, same shape, 2 float, 2 sunk. What we're going to try to do is we're going to make the clay into a new shape to help make that float. So at the next break in this video, what I want you to do is take out your science lab books and do some drawings. What could you do to the clay cylinder? How could you reshape it into a way that you hypothesize will actually make it float? So we're going to stop the video now, and I want you to take out your pencils, scientists, your notebooks, draw a clay before and after, and then we'll come back together and test. Have fun. Okay, scientists, we're back. I've got my cup of water, my glass of tap water, fresh tap water, no salty mixtures today. And I've got my clay. I made 2 identical weights of clay, 14.5 paper clips. One is flat like a pancake, and the other one is more shaped like a sausage. So we're having breakfast for science today. And we're going to test how these respond with floating and sinking. So let's do the sausage first, same weight. So we're seeing the shape affect floating and sinking. And that actually sunk, it's just resting on the bottom. And let's try the pancake shape. And that floated for a second or so, and then it sunk. So the next question is, do you think we can make the clay float? So scientists, what we discovered is even when we change the shape into some breakfast delicacies, a sausage and a pancake, both objects, which weigh the same thing, mind you, they both actually sunk. The interesting thing was the pancake setup sunk a little slower. It hesitated. So my question is, our question to you is, what can we do? Can we think about a way we can make our clay float? So is there a way that we can reshape the clay so that it will float? Making a sink or float is what we're here to do. So what I want you to do is draw that in your notebook, draw some different designs for how you can make this clay float. And if you're working from home and you've got clay or Play-Doh, go ahead and recreate this whole experiment with making different shapes, making sinkers, and then trying to reshape those if they're malleable, if you're able to manipulate them into new shapes in an attempt to make them float. So right now, head to your notebook, do some drawings. Maybe you've already got water and materials out and you're working right alongside me, virtually, digitally, and give that a shot. So right now I'm manipulating my clay into a shape that I think will have a better chance at floating. You can probably imagine what I'm doing. So stop it right now, do some drawings, make some shapes, and it might look something like this. Now, if you don't want to see, pause it right now. I've got a little pinch pot, if you will. High sides, boat-shaped clay. I'm making sure that there's no holes in the bottom. And it's relatively thin and the weight is dispersed out. I think about myself floating in a pool. It's easiest if I spread my arms and legs out. Spread that surface area, that disbursement of weight. All right, so I'm gonna fill the water back up and we'll see what happens. Okay, here we go, scientists, moment of truth. I've got my little clay boat. It's the same exact weight as it was before when it sunk. And we're gonna test it out. And there you have it, scientists. Making a sink or float. Have fun and see if you can recreate this with some objects in your own house. We recommend Play-Doh. And thanks for tuning in today. Have a great day.